All right, guys, let's get into the meat of this lesson. We need to graph an exponential function. So if I am given the graph of y equals 2x, let's plug in some values. And so I picked some random but strategic points here. And so let's plug these values in. So if I plug in my -2 in place of x, that means we're going to have 2 to the -2 power. I need this positive. So this is actually 1/2 squared. And so we get 1/4. So I'm going to go ahead and put that in. We got 2 and 1/4. Let's plug in -1. We got 2 to the negative first, which is 1/2 to the first. That's how you turn that exponent positive. You put it down to the denominator. So that is 1/2, okay, which is right there. I put in 0. I've got 2 to the 0 power. 2, anything to the 0 power is 1. So we have 0, 1. Now I have 2 to the first, which is 2. Now I have 2 squared, which is 4. And I have 2 cubed, which is 8. Okay, so there is my graph. Now, before I connect some points, let's think about what's happening here. I kind of went from left to right, and as you can see, as you are going, as these x's are getting bigger, these values are getting bigger as well. Specifically, though, they are what? They are doubling. 1/4 times 2 is 1/2. 2 halves is a whole. 1 times 2 is 2, times 2 is 4, times 2 is 8. It's all doubling. So if I was to go back the other way, you go 8 to 4, that's cutting it in half, in half, in half, in half, in half. So what's going to happen with 1/4? You're going to cut it in half again. And that would be 1/8. And you're going to cut that in half. You're going to get 1/16. You're going to cut that in half. You're going to get 1/32. You're going to cut that in half. You're going to get 1/64. As this keeps getting smaller, these keep getting smaller, and they keep getting closer and closer to 0, but it's never ever going to approach 0. So right here, I have a horizontal asymptote at y equals 0. So it's HA, a horizontal asymptote at y equals 0. So when I make my graph here, I don't want to cross that x-axis. And there is my exponential. Now you can see my line technically goes up, right? But the thing is actually getting closer and closer to that line forever. So let's talk about this graph. What is its domain? As you go from left to right, you go arrow to arrow. This is -infinity to infinity. I can plug in any number I want into this x. What about its range? As I go from the bottom to the top, it's got a horizontal asymptote right here at 0. And then it's going to keep going up really quickly forever. So this is 0 to infinity. And one more thing that we want to make a note of is that this graph, no matter where you are, is always increasing. Okay. Now, this is when my base is 2. When my base is 2, these keep doubling every time. Now, I want to show you, and what am I sharing here? Am I sharing my screen? Yes, okay. So here is my graph on Desmos. Okay, I have 2 to the x power. And so here is my graph. Let's see if I can get rid of that. Okay. Now, what happens when I have 3 cubed? Nope, let's try 3 to the x power. Well, let's think about it. If I put in 1 for x, you got 3. If you put in 2, now it's 3 squared, which is 9. Now if you put in 3, you've got 3 cubed, which is 27. If you put in 4, you've got 3 to the 4th, which is 81. So what's happening to those numbers? They are getting bigger a lot faster. And so as your base gets bigger, this now is going to get bigger a lot quicker. And it's also going to get closer to 0 a little bit quicker as well. So as your base gets bigger, this now gets more steep, more steep, more steep, more steep, and so on. Now, all of these do have one thing, well, not one thing only, but one thing in common. And where do all of these cross that y-axis? Right here at 0, 1. And that should make sense. No matter when you put in 0 here, 2 to the 0, 3 to the 0, 4 to the 0, 5 to the 0, and so on, anything to the 0 power is 1. So they all have the same y-intercept. Now, if you remember from the second video, we talked about exponential functions being in the form of CA to the x power. And it said that A, your base, cannot equal 1. So if I have 1 to the x power, that does not look the same. Because now when you do 1 squared, 1 cubed, 1 to the 4th, 1 to the 5th, 1 times however many ones you have is going to be a constant linear equation there. So it is never, your base can never be 1. It can be 1.1, which is pretty shallow. It can be 1.01, which is even more shallow. It almost looks like a line, but it is going to slightly, and that's a really, really slightly, ever so much go up. So let's maybe not make it quite so small so we can get a little bit more of a visual. Okay, there's 0.111, 0.09 to the x power. Okay, so it can be bigger than 1, and it can be slightly bigger than 1, but it cannot be exactly 1.